We're John, Bobby Ridge, and today we have Reason. All right. Can you give us a brief description of who you are, so our people on our channel know, and also uh, how long have you been involved in life extension, and uh, and what's the ongoing research looking like?
Well, okay, so I've been around in this field for, as an advocate at least, for most of the last 20 years. I started a website way back when, around the turn of the century, but got more serious about it around 2004 when I launched Fight Aging, the blog that's still going and on which I just offer a feed of interesting research. And along the way, I started collaborating with the Methuselah Foundation, the SENS Research Foundation. I helped raise funds for them, generally just put out a voice, helped draw new people into the community. And along the way, a few years ago, once the funding started to show up for companies, I helped do angel investing. Invested in a number of companies in the space, and then last year I started a company myself in order to work on a couple of projects that I felt were compelling enough and that nobody was doing. One of the interesting things about this space is that there are, thanks to the fact that aging research was very effectively suppressed for much of the last 30, 40 years, because the scientific community was hugely allergic to what the non-scientific community was doing and claiming. This means there are just an enormous number of really interesting projects that have not been carried forward and are just sitting there waiting for someone to champion them. So we picked up a couple and we're championing them, and as are a number of other people and hopefully a growing number of entrepreneurs arriving, attracted by the very large amount of venture funding that's presently available for early stage work in this field.
You said research was like suppressed. Like, what do you mean, like, by that? Because I know that with aging and fighting aging, it's kind of had a label attached to it. Like, these guys are kind of silly, fighting aging. That's kind of, thinking founders youth or stuff like that. But what did you find?
Right, so it's been an uphill battle. I think like things have turned around now, but it's been an uphill battle to convince people that this was a legitimate field, at least for the first decade of this century. Things got better after senolytics started to be proven, because senolytics are clearly reversing aging and doing tremendous things and are highly reliable and cheap. So it's very hard for anybody to sit there and argue, no, you're not actually doing anything relevant, because the science is absolutely showing that things are being done to cause rejuvenation. And there are other things, other lines of work, such as induced pluripotency in vivo, the various upregulation of stress responses that are not, strictly speaking, rejuvenation, but are nonetheless doing things that look fairly good in old animals. And therefore, again, it's rather hard for people to sit there and argue with a straight face that, no, you're talking nonsense, nothing's been proven yet, because plenty of things have been demonstrated. It's a burgeoning field. At this point, anyone who's suggesting that this is all silly is just out of the loop.
Yeah, it's very interesting.
But prior to this point, it was very problematic. The old guard of the research community, the aging research community, were very, very adamant that nobody was to do anything that might look like what was being claimed in the anti-aging supplements and nonsense area, which started around the 70s. And it was basically that, the anti-aging supplements, pills, potions, and fraud industry that caused the scientists to basically back away, which was a bad choice on the part of the scientific community. It was a stupid thing to do. We could have been so much further ahead. Senescent cells were understood well enough to think that they may be involved in aging, certainly 20 years ago, probably more like 40 years ago. And the drugs that are currently being used to clear senescent cells, they're 25 years old, some of them. And certainly efforts could have been put in prior to that, in, let's say, the 80s, in order to clear senescent cells, but it never happened. And now here we are, it's nearly 2020, and we're only just getting going on this.
Oh yeah, I wanted to say for one last thing. Hold on, Bobby. Yeah, it took me convincing about that there is anti-aging with the whole Bobby. It took me a while to convince me just with the. I'm a fairly young guy, but yeah, I went to school for biology and stuff. And yeah, it's very interesting, but it takes a it's a paradigm shift almost to kind of think that way. But you said like in the 70s and 80s, like did a lot of people were trying to sell supplements and pills that would quote reverse aging, and as a result, people scientists kind of got away from that because it's kind of like a reminds me of like a uh, elixir, to keep you young forever. I mean, there's bound to be some kind of like,
Right.
or to try and take advantage of any that kind of idea.
It was absolutely fraud, and optimism on part of many of those people, because the best frauds are carried out by people who actually believe the fraud they're carrying out.
Yeah,
So, I mean, it's a challenge because many of these groups still exist and their principles do have their heart in the right place. I mean, look at the Life Extension Foundation, who sell a bunch of stuff that clearly does not do what it's claimed to do. They cherry pick research, and yet, they've given far more money to serious research, doing serious things than I ever will, given my income. And they also, now that things are coming along that actually work, they're attempting to pick them up and distribute them and get them to more people. So they're not completely terrible, but they are terrible.
I'm surprised the aging community hasn't been more popular, especially since there's been small molecules since like the 80s and 90s that have been extending health span and lifespan, average lifespan, median lifespan, and maximum lifespan quite a bit too. There's L-diprenols in the late 80s extended average lifespan by 30%, and there's centoquivin, ETDA or EDTA. I have like a whole list of various life extension molecules.
Um, right. You have to understand that most of those studies are junk, and most of those results do not get replicated. The pattern of this is as soon as the NIH interventions testing group goes to try something, they find that it does not work or the effect size is actually very small in mice. What happened for a lot of work prior to the 90s was that the calorie restriction was not well understood in the research community and the size of the effect. So anything you do to mice that makes them eat slightly less, guess what? They're going to live longer. And that's the problem with almost all studies prior to the 90s that showed extension of life in mice or other animals, is that they were basically causing calorie restriction in some way, shape, or form. So you have to disregard basically everything to do with anything prior to that date, and after that you have to really consider strongly: is this upregulating stress response mechanisms? Is it some form of calorie restriction or exercise mimetic? If it is, then we already know what that does in humans, which is next to nothing, because we know what calorie restriction and exercise do in humans, and they do not extend life by any significant amount, even though they're pretty good for health. So everybody who's doing things along the lines of mTOR inhibitors, autophagy upregulation, these are drugs that are going to do much the same thing as regular serious exercise or calorie restriction. And that's not a small thing in the context of modern medicine, but that's because modern medicine for aging 99% sucks. It's really very marginal. It's not useful in the grand scheme of things. We are at the point of a revolution. This is a huge phase change taking place right now with the advent of senolytics and what will come after senolytics, because the effect sizes are going to be enormous compared to what's been done before. If you can turn off chronic inflammation in an older person, how much longer are they going to live? We don't know, but we know that chronic inflammation drives all of the common age-related diseases. It's very, very important. And if we suddenly get rid of it by removing senescent cells, that's going to be pretty significant compared to anything that anybody else has done for mortality rates and disability and disease in old age. None of the rest of what's going on can match up to that.
I've noticed that trend with the various life extension small molecules before the 2000s. Later on in the 2000s, studies have replicated it, like the 30% extensions of lifespan or 20%. They were like way smaller.
Uh-huh.
Which is too bad. But your fighaging.org website is really great, and you've been working on it since 2004.
Something along those lines. You know, my own old age is approaching within the scope of my doing things in this community. Sad to say, but it's by now it's quite a habit. It's optimized and fairly easy to do, and I just crank this stuff out on a daily basis, and I think it still helps.
Yeah, and I've been seeing quite a bit of funding for longevity and aging research. Like Juvenescence just raised $100 million for their fund.
There's a couple of $100 million funds out there now, and of course what they're doing at their level is to basically seed the ground to attract billions into the companies they're putting forward so they can go through the regulatory pipeline. Most of what these companies are doing is not what I would class as rejuvenation, but I'm fairly picky about my definition. If it's not repairing damage after the SENS model, then it's probably not a form of rejuvenation, which doesn't mean it can't be useful, but it does mean it's probably less likely to be very, very useful.
Yeah, and I was wondering, could you tell you talked about senolytics a lot. Can you tell our viewers kind of what that is and why you find it so promising?
Okay, well, senolytics, this is the name given to therapies that selectively destroy senescent cells. Senescent cells are those that accumulate in the body with age for various reasons, and the body becomes less adept at getting rid of them for various reasons. Senescent cells are really great in the short term. They help suppress cancerous cells. They help to do wound healing. They are necessary as the end of life for a somatic cell once it becomes too damaged to replicate or just reaches its Hayflick limit on replication. So they're a necessary part of our physiology. The trouble is they don't all die. They're supposed to die. They're supposed to either suicide or get destroyed by the immune system, but a tiny number of them linger. And in lingering, they sit there and pump out these signals that are supposed to help with regeneration and are supposed to attract the immune system and do all these other things. And you know what's good for the short term is really, really, really terrible when it happens in large volume over the long term. Even if 1% of your cells are senescent, you are in really, really bad shape. Those cells are destroying all sorts of necessary processes, disrupting regeneration, producing fibrosis in your tissues, and so on and so forth. They've been shown to be relevant in almost all age-related diseases studied to date. And in diseases like arthritis, they are the primary cause. So if you can get rid of them, and people in the self-experimentation community are doing that right now, you can do things like treat your arthritis, treat your inflammatory bowel disease, and the human trials are ongoing and in one case complete, and it all looks pretty good so far. The effect size is so large that even clearing 25 to 50% of these cells in a few tissues is producing very reliable effects in animals and certainly noticeable effects in humans.
That's awesome.
So, the other most important thing about this is that these drugs are very cheap, and the first of them are available now. So there's really, this is going to cause some very interesting fights in the years ahead because the FDA can't possibly stop people from using senolytics. Since one of the drugs is dasatinib is an approved chemotherapeutic, and it can be used off-label. So at this point, there's something of a push to get physician networks going who can prescribe dasatinib to people. But even so, if you just want to go get it, that's pretty easy.
What's that called again?
Dasatinib. It's a chemotherapeutic drug. It's used in combination with quercetin, and that is the quercetin and dasatinib is the primary senolytic studied in animal models. Though of course, like if people are going to do this, there's a big long blurb on my website about the sort of responsibility one has to take if self-experimenting with things, read the literature, understand what you're doing, accept responsibility, all that fun stuff. But I mean, the upside the potential upside is so large, even for people who want to sit down for 2 years and wait for the next studies to come out, that it's very hard to see this not taking off in a big way. And certainly there are groups pushing very hard to get senolytics further out there into the communities. It's not a wait for development for the next 10 years thing. It's a, these drugs exist now and we need to get them tested better and more people to know about them type of thing.
Yeah, right now really is the time to start investing. Even though we see, it seems like there's quite a bit of money being poured into aging research and life extension or longevity research. Really, we need so much more. And you even have on your website a link for your consultation. People can email you for a consultation from you to ask about how to invest in this research, since this research is complex.
This is
So
very
I
true.
highly recommend everyone check that out and email Reason if you're an investor.
Thank you. That's very true. I really like to help new people coming into the community, investors, entrepreneurs, or indeed anybody. That's the whole point of Fight Aging, is to help people get a leg up and get a good start on understanding the complexities of the science and who to talk to in the community, who's here's already, who's doing what. This stuff is still, we're still small enough that there's nobody really out there doing the sort of, here's our community in a nutshell on an ongoing basis. Give it another 5 years, and I think there will be more people. But right now, it's still comparatively small and getting started.
Aubrey, he works for the SENS Foundation, and I think you're talking about that. Can you tell us more about the work they do?
So the SENS Research Foundation spun off from the Methuselah Foundation back in the day to carry forward the SENS research programs. Specifically, the Methuselah Foundation nowadays is more focused on an eclectic set of other research and tissue engineering. The SENS Research Foundation focuses specifically on the 7 categories of damage that are thought to cause aging. There is a tremendous amount of work this is not like a novel idea on their part. They're simply saying, look at all this evidence that has been gathered over the last century, and here is what the evidence points to. And so far, they have been proven exactly right. In 2002, Aubrey de Grey and his co-authors said, let's clear senescent cells because we believe they're a cause of aging. And it may have taken, the better part of 20 years for everybody else to come around, but they were absolutely right. And the evidence is very compelling for them to be right about all of the other 6 items as well. And things have moved forward far enough in the last decade that there's a lot of researchers now working on these things. Well, a lot is more than 0 in our world. Certainly many of these programs need much more support in order to move forward rapidly. But there are people working on all of these, and there are companies working on at least some of these. So we should expect to see over the next 10 years a plethora of things that are emerging and will be as influential as senolytics are right now, though the influence of senolytics is not yet widely appreciated, just how good they are. But we will see more of that. We'll see the categories include things like metabolic byproducts that build up in cells and are hard for us to break down. And this causes, for example, problems in cell maintenance in old cells in the central nervous system when the recycling system gets gummed up with metabolic byproducts that can't be broken down. Things like amyloids in neurodegenerative diseases. There's other forms of protein aggregate that we should probably be doing something about getting rid of. Mitochondrial damage, that's important. Are the energy producing parts of our cells become really quite disabled in later life in several different ways, and fixing that would be very influential.
Yeah, I feel like life extension and age reversal research is so just morally superior and philanthropic. I can't imagine people being really corrupt like you see in the current healthcare system, because what happens if you're corrupt or producing faulty drugs is you're preventing your own age reversal or life extension. And I think that's just going to be so much more obvious with the even greater results that we have even now.
Well, the problems in our medical community are many, and largely result from regulatory incentives, I feel. The actual cost of doing things is considerably small, very small, compared to the cost of then getting through the regulatory system. And I think we will see, as cheap therapies like senolytics start to become more widely appreciated, we will see an awful lot of medical tourism, regulatory arbitrage, as people find other jurisdictions to evade the costs of the regulatory system as it exists, while still doing what is morally necessary to prove that these things work. Because conducting a trial is cheap. It's conducting a trial the way the FDA wants you to that's expensive. And 95% of what the FDA wants is absolutely unnecessary if you're trying to detect a large effect in a sizable population.
Yeah, hopefully we see some changes in the FDA approval process. So you're the co-founder and CEO of Repair Biotechnologies, and I'll provide a link in the description. And everyone should definitely go check that out and provide donations to Reason's company. Why did you choose to target the thymus first?
Well, it's a funny story there. So we started off as a gene therapy concern. That was our starting point. What are we going to do? Obviously, gene therapies, because gene therapies are they're a wave. They will become much more common, much more effective. And there are several approaches right now that have the potential to become the sort of 80-20 gene therapy that just basically works, versus the gene therapies of past years, which were really hard to produce, and everything had to be handcrafted and tested really well, and in order to get it anywhere near the point of being useful. So starting from gene therapies, we said, okay, what are the interesting genes we can do? And we ended up chatting to somebody who unfortunately died last year, who was working on follistatin gene therapy, akin to Liz Parrish's work, but via a different vector mechanism, as Liz used a early approach that's not very efficient and requires a great deal of work to actually get it to a stage where it can be efficient. So we chatted to this fellow, and then after we left, we said, well, okay, why not FOXM1 rather than follistatin? Because I've just been looking at FOXM1 at the time again, and it's something that keeps cropping up on Fight Aging over the years. FOXM1 is the controlling gene for thymic growth and activity. And there's a tremendous, like our thinking process early in the company was, let's find something that's really compelling, that where there's absolutely no doubt that it works, but nobody's really worked on it aggressively. And follistatin is one example of that. There's absolutely no doubt that it works, but few people, let's say, nobody at the time was really aggressively carrying it forward, because BioViva was in its transition phase. But I think now there's a couple of people looking at it. FOXM1, bizarrely, is in that category of a very important gene and a very easy target for upregulation, where nobody's really working on it for no good reasons. My personal belief is that the community moved on to tissue engineering at the time at which the FOXM1 work was just coming to an interesting place, and that was purely just one of those weird little cultural things. So we picked it up and started working on it, going pretty well. And the reason, obviously the reason why we settled there is happens at the outset. But once you go in and look at it and evaluate the quality of the project, it's very, very clear that it's the only challenge is just building the therapy. The mechanism very clearly works. We have 20 years of data to support that.
And so, in the thymus, that's the first organ to age, right? It ages the fastest out of all the organs.
Well, that's an interesting question as to whether we're going to call that aging. So I think the literature is kind of clear on the point that what the thymus does in early life, let's say before you get to 20, is not the same thing as what it's doing after that. These are two separate processes. So the thymus involutes, quite sizably, degrades and becomes smaller once you become an adult immediately. And we can assume that this is because evolution has decided that front-loading the immune system is great, and for whatever reason, if you kept it going, you'd run into some sort of other problem later on in the course of a normal life in prehistory. Nothing that would apply to us nowadays, of course. What happens later is that chronic inflammation probably causes a decline in FOXM1 levels through mechanisms that have yet to be explored. And that leads to a loss of growth and tissue maintenance in the thymus. And then, of course, the thymus is responsible for allowing T cells to mature, to participate in the adaptive immune system. So less thymic tissue means fewer T cells, and your immune system becomes ever more like a closed population that doesn't get many replacements and becomes ever more cluttered with useless and unhelpful cells. So you become ever less capable of doing all the things that the immune system has to do, which is everything from suppressing cancer to defending against pathogens, destroying senescent cells, all the other stuff. Interestingly, if you take a model of cancer risk and a model of thymic degeneration, they match pretty much exactly, which is a very interesting thing to consider. So the objective here for us is to just make the thymus big again, make it, give it a lot of tissue, make it start to pump out T cells at the rate it did when you were 20. Or if we get back to 40, that would be great. And that's the current goal.
Okay, yeah, the two classes you're focusing on, it says here on your website for Repair Biotechnologies, is to repair thymic atrophy and cholesterol catabolism.
So the cholesterol side of the house is a totally separate project that we picked up because it was too good to pass up on. It's actually, I'm very interested in the dealing with oxidized cholesterol part of the spectrum. It's been something I've been watching for a while and waiting for somebody to get their act together for. And of course now it's like buses, you wait 20 years and then a bunch of them come along at once because the people come to that point. I think the SENS Research Foundation is spinning out a company to do something similar as well. So so atherosclerosis, okay, you understand that's a condition in which you get fatty deposits building up in your blood vessels that narrow them and make them weak, and eventually one of your blood vessels explodes or gets blocked and you die from a heart attack or stroke. This is not a condition of fat in the bloodstream. Fat in the bloodstream is a primary focus for people who've been trying to treat atherosclerosis. And statins that reduce cholesterol in the bloodstream have been tremendously successful for a medicine that isn't actually addressing an underlying cause of the condition. The underlying cause of the condition is that these cells called macrophages, which are responsible for extracting the cholesterol when it ends up in your blood vessel walls and handing it back to the bloodstream to pass off to the liver, these cells become dysfunctional with age. They start to have real issues because they get overwhelmed by oxidized cholesterol. And oxidized cholesterols exist because of various other problems in your metabolism that build up with aging, such as the aforementioned dysfunctional mitochondria, which kick out oxidative molecules quite readily. So you have these oxidized cholesterols that are causing your macrophages to go crazy and become senescent and become inflammatory and stop doing their jobs and die. And while they're doing that, they themselves that say, help, send more macrophages. So you have this feedback loop once a plaque starts, and it just ends up being a big mass of dead macrophages and horrible cholesterols, and all the new macrophages that come in just die and add to it. So what you want to do here is make macrophages invulnerable to oxidized cholesterol, or just invulnerable to cholesterol in general. And that is what we're doing. We are licensed to technology that allows us to insert a pathway into macrophages that allows them to consume the cholesterol and therefore not be affected by it. And that, in theory, should solve the whole problem. But how much of the whole problem it solves, we'll let you know once our mouse studies are finished.
Okay. Could you tell us if you're using small molecules or gene therapies or cell therapy?
In that case, where that one, your option is basically, let's go do a gene therapy and target macrophages in situ, or take macrophages and build a cell line, and then deliver macrophages from the cell line to the patients. And it's sort of an open question as to which of those will turn out to be more effective. And I don't have a horse in that race. We'll just do the studies and see what happens.
Yeah, awesome. And so you have your master's in astrophysics, and then you figured out how important it is to extend our health span and lifespan, and you started to really focus on learning about this field. I think that's really great to see you, and there's a few others like how promising life extension research is, and starts investing in stem cells. And there's a few others like that, and that's really great. That I think we really need more people like you to. You don't really need to be to have a PhD inside a field of some sort of biotechnology to get involved, and just start learning about it and get involved. Since we all have the real chance of dying soon, someday.
This is particularly true for entrepreneurs. Anybody who can be a business entrepreneur can come in and find a scientist to partner with and get going on something interesting. And I've met a bunch of people who are heading in that direction. It might take you a year or two to figure out enough of the science to be making good choices. But primarily, you can always offer your business experience as somebody who can help to expand this field. And anybody who wants to take longer, like I did, to really learn the science and participate in other ways, there is plenty of room to participate. It's definitely it's an open field. There's a lot of opportunity here for people to make a difference.
Yeah, just imagine once this is like really mainstream, and people, by the hundreds of millions, really are passionately trying to achieve the longevity, escape velocity, extended lifespans past 120. Yeah, I just think that's going to be such a fantastic time.
It will be interesting times, that's for certain. There's going to be a lot of fighting in between here and there over medical regulation and various other things. But I think the trajectory is only upward in terms of investment in the field and interest in the field. Because, as soon as somebody figures out, maybe I don't have to have my arthritis, it's all downhill on the persuasion slope from thereafter. It gets a lot easier.
Yeah, and with people alive, you had to continue to treat them too over time. Unless we find something that can extend your lifespan by like 300%, which is probably likely.
Eventually, but it will be many things. The way to think about it is machines and damage. I mean, we are a machine. Damage causes a shortening of lifespan as well as a degrading of capabilities, and it's all about when your component parts fail. So to the extent that we are machines and damage is the defining feature of our lifespan, so long as you can just periodically keep repairing the damage, you're fine. And the subtlety there is, of course, it's much easier to repair the damage before the damage has then gone on to cause all sorts of other problems. So to pick one example, atherosclerosis with the fatty deposits, if you prevent it, your blood vessels will never become distorted and weakened. But if you catch it late, then it doesn't matter if you get rid of the fatty deposits. You still have distorted, weakened blood vessels. And that would require something else, and a quite challenging something else, actually, to go fix it. But it has to be said that a surprising amount of the secondary damage of aging reverses if you get rid of the underlying cause. For example, I think just within the last year, somebody demonstrated, and I would never have said that this was going to be true prior to having been done. Somebody demonstrated that the cardiac hypertrophy, the growth and weakening of your heart muscle, that occurs due to heart failure due to a variety of problems such as inflammation, senescent cells, hypertension. They gave mice with hypertrophy senolytics to remove senescent cells in the heart, and their hypertrophy actually reversed. The muscle repaired itself back to like the way it should have been before. I would have said that that was not going to happen. So maybe we'll be pleasantly surprised by a lot of it, but it's still the case that if you're late in aging, many of what will be the most effective therapies in the future will only partially help you.
That's excellent.
That's why they always say prevention is often way better than treatment.
Prevention is always better, and periodic repair of the damage the moment it gets to the point at which it might be slightly problematic is a lot better than waiting until later. So of course many of us don't have the option for anything other than waiting until later because the therapies don't exist yet.
Are you currently taking any of the promising age reversal or life extension treatments?
So I gave, because I do actually have a self-experimentation section up at Fight Aging, and I dislike talking about things unless I've actually tried it. So I have tried combinations of senolytics, even though I'm too young to really benefit from them in any way. Senescent cell profiles go much the same way as cancer risk profiles. If you're not obese or not a type 2 diabetic, then it's not going to do much for you until you're that age. I've given the whole NAD plus enhancement nicotinamide riboside thing a try for the sake of, okay, let's see what it does. And the answer is not a great deal for someone my age and fitness, but something. But measuring it is really challenging because until you have a really significant effect, it's pretty hard to actually sit there as a self-experimenter and see that something happens. Because you have to look like kidney function or cardiovascular function, which boils down to things with very large error bars in the measurements. So the story is that people should probably be taking these things preventively in a sensible way, but probably is not the same as certainly, and one has to make one's own choices about this sort of thing.
Yeah, there's quite a few of off-label and dietary are out there extending mice lifespan, and there's even human studies so that you can get a sense of the adverse side effects and dosage amount. Of course, you'd have to our viewers listening, you make sure you talk to your doctor and get their advice about how to take these off-label or dietary supplements, and if they work well with any medication you're taking.
And also bear in mind that mice are not people, and mice respond much more plastically in lifespan to anything that upregulates stress responses.
Yeah.
So almost everything demonstrated to extend life in mice will do next to nothing in people.
Yeah, which is really too bad. It'd be awesome to see some of these 30% increases, 40% increases translate into humans. Especially these gene therapies, that'd be really awesome if we see those translate, because there's some that are like in the upper 40% of increasing lifespan, average and maximum. And
well,
so
if you look at the record holders for mice, which is sort of a 60% or so increase, that's growth hormone knockout. I think one of the growth hormone disabling mice. We actually have a human population of those, the Laurent dwarves, who Laurent syndrome causes dwarfism. It does not cause people to live 60% longer, I can assure you. In fact, it looks very unlikely that they live any longer than normal people. They might be slightly more resistant to diabetes, but there isn't even enough data to say that for certain.
Yeah. So we haven't seen an extension of lifespan in the dwarf population in humans?
Nope. So there's some small, there's some evidence that shorter people live longer in the sense of, maybe a year or two. But, that's just that it's hard to say why.
Yeah. Are you currently signed up to cryonics?
I am, in fact. Yes, I'm signed up with Alcor.
Awesome. Yeah, I was gonna sign up soon. Um, and
It's a
that
good
really needs to
idea.
be more mainstream. Way too many people are being buried or cremated when you can have the real opportunity to be revived in the future by just crowd preserving yourself.
The operative word is opportunity here. It's certainly not a certainty, but it's
Yeah,
much larger than the chances you will have after being buried, which are zero.
yeah, yeah, for real. And excellent. That was all our questions. Um,
Cool.
thanks so much for talking with us, Reason.
That was a pleasure.
So
Yeah,
much.
hopefully we can talk in the future more about your company and your website where you publish articles. I highly
Well,
recommend everyone.
come out to the conferences. If you come attend the conferences in our community, there's a whole bunch of them. Many of them are pretty interesting. You'll meet some quite interesting people.
Any of them
Yeah,
coming?
can you provide some examples?
The Life Extension Advocacy Foundation runs a conference yearly, as does the SENS Research Foundation with Forever Healthy. Both of those are great.
Do they ever have conferences in California?
There's a bunch of them out in California, actually, mostly more scientific ones, now that the SENS conferences have moved to Berlin.
All right, we'll have to go to some of those. Maybe you'll see us there.
Yeah, make sure everyone reads Reason's articles and publish them on social media. It's really a great way to keep up with aging research and to understand the hard science. Reason does a great job at explaining it all at a way for anyone to understand. And
Thank you,
yeah,
guys.
thanks a lot, Reason, for talking with us. And have a nice day.
Oh, it was a pleasure. Thank you.
All right, have a good one. Thank you.